Hi, everyone. Welcome to the third episode of the Rubicon podcast. Today, we have some great news from the hosts. Along with that, we're going to discuss small models and the audio agent stack. Vishwesh, congratulations on the new raise. Can you tell us all about it?
Sure. So we recently, I think just last week, announced our Series A, $22 million, co-led by Andreessen Horowitz and DCBC. So we're really excited to continue kind of partnering with Vinita and Jay at Andreessen. Mar at Pair also kind of continued participating in the round. And we're really excited to welcome James Hardiman from DCBC. So really what we're kind of like raising the funds for is we also announced earlier in May our first flagship diagnostic in bladder cancer to predict a response to frontline immunotherapy in bladder cancer. And so we kind of announced those results at the AUA a urology conference with the two podium presentations. And really, what we're kind of in the midst of over the rest of this year is really scaling out adoption of our first test and really scaling into a large number of other cancers.
Congratulations. That sounds awesome. I'm sure the team is really excited with the news.
Yeah, no, I think it's a super exciting time.
Yeah, awesome. So let's jump right in and talk about small models because it feels like that's been an interesting topic that a lot of enterprises and SMBs have been talking about. Govind, I know you work with a ton of these companies that are trying to figure out if they should build their own small models or how to think about using foundation models. Can you give us some background in terms of where you see opportunities in the space?
And I think like it is very much a matter. It's very much a function of the cost uh, of the very large closed source models that people currently use or that people start off with because they're very easy to prompt. I think I think the main thing here is that at scale or at even some like medium of scale, you start seeing costs associated with running language models spike, right? And so if you have these really long prompts that you're using to specify the behavior of these trillion parameter models, you're obviously going to be spending a lot, right? And OpenAI and Anthropic are obviously spending a lot of time optimizing their inference stack and attempting to pass on those savings to the user. But at the end of the day, the vast majority of reasons that people move to smaller models, is because of just cost, right? And there's other very valuable benefits that people don't currently see, but they will soon. But like at least initially, the idea is that okay, now that you've collected like a thousand input output pairs, thousand logs basically of your GPT-4 interactions, then you can distill that into a smaller model like Llama 3 8B or something, right? And and the reality is actually that you don't even need to fine tune for many of these use cases. Like people don't realize how good the smaller models have become at this point. Like 8B instruct model is really good, and so you can actually get pretty far by prompting 8B in very much a similar way as you would prompt GPT-4, right? But if you want consistency, it's good to fine tune. And if you have really long prompts, then the behavior that is specified or encoded by those prompts, you can basically compile into the model by fine tuning. So the big reason is cost savings. The secondary reasons are actually the fact that you can actually improve large models once you put them in production. So suppose you're building some GPT-4 based RAG system. Okay, you've collected all this preference data from the user about how good your responses are. You can't actually do anything with that data if you have this closed model sitting somewhere in your system, right? Because you need like a fully differentiable end-to-end system to actually make improvements with reinforcement learning and so on. And so there too, for like continuous improvement use cases, smaller models turn out to be quite valuable and quite helpful and actually quite necessary, right? But I think at least the current moment, not many people are thinking that far ahead. It's very early innings.
I've got a question over here. Do you think the definition of like what a small model is going to change like kind of 2 years from now? Because you could assume that like a couple of years ago that a 10 million, 100 million parameter model was like kind of considered more small, and like now it's 8 billion, and obviously there's kind of like drastic jumps in performance, right? So it is kind of understandable why this is like 8 billion is the new smarter model. But do you think it like kind of plateaus at 8 billion because you can just cram so much more reasoning into kind of models of size 8 billion, or do you think it just continues to scale up over the next 2 to 3 years?
I mean, I think it's sort of it'll plateau there in some part because the kind of hardware that is available to the average end user sort of limits the size of what you would refer to as a small model. And like again, a part of the reason that you refer to 10 million parameter models as small models back in the day is because I guess large models were like billion parameter models at most, right? And
Yep.
that number is changing, but like even a billion parameter model, you can still fit on a 40 gig GPU, right? Uh, 8 billion parameter models you can fit on a 24 GB GPU, right? But I think when you start getting to like 30, like 13 billion parameters, maybe is a sweet spot, right? But I think once you
Hmm.
start getting like 30 billion parameter models, you really can't fit that on a consumer GPU unless you do some kind of sharding or quantization. So
Yeah.
I don't I think there we can actually go very very far with 8B models, and I mean I've seen with 70B models I've seen performance surpassing that of Claude Opus for many tasks, even without fine tuning, just really clever prompting. So I don't know, jury's out on what even like the large model exactly requires, right?
And the other thing is also the fact that these enterprises have like different kinds of use cases, right? Like right now, like the most rudimentary use case is like the whole chatbot use case, which we keep coming back to because that feels like the easiest use case that most people want to apply to, or like a co-pilot for any of these for to think about websites and to think about automations. And for use cases like those, it feels like you don't need like a 70B model. And then along with that, Goen, can you also talk a little bit about real deployment in production and what that looks like, because it feels like for most of these enterprises they have all of this proprietary data that they don't want even sometimes going in the cloud. Many of these legacy players want like on-prem solutions. Like you mentioned, like hardware is one piece of things, and then there is latency, which also, like, of course, like small models help with, just because these are smaller models they can probably run quicker and potentially have higher quality. How do you think about like actually like the process of actually putting these models into production, and how much better these small models can be from a latency and from a deployment perspective?
And from a latency perspective, I think for a period of time, Claude Haiku was sort of perfect. Claude's closed source like smallest model was sort of perfect for it was really really low latency and it was pretty good. I think now Gemini 1.5 Flash or something has taken that spot, but I mean I looked at a leaderboard the other day and they were saying that 8B instruct, like Llama 3 8B instruct, edges out uh, the Flash model, which is sort of absurd to me because the Flash model is distilled from 1.5 Pro, like the giant trillion parameter
Yeah.
model. So don't really know what's happening there. We'll need to look into it further. But yeah, like you said, 8B models are significantly cheaper to run and significantly lower latency to run as well. It's like non-trivially a function of like the inference engine that you use and the GPU that you have access to, right? But like if you switch from say uh in 4.0 is supposed to be really fast, but I found that like an optimized deployment of 3B is like 10x faster.
Yeah. Also, the one tangential point that I love about what's happening in the AI world is like we literally have leaderboards because things are moving so quickly, and like tech and infrastructure is getting commoditized so quickly that like as soon as a new model comes out, it like is on the top of the leaderboard, and you can literally go check like what are people using, what are people deploying. And I think like that is such like an exciting thing because I landed here at Stanford probably like late 2018. At least in the last 6 years, even at the height of like 21, I don't feel like there was so much excitement around like real technology that was being built, and that's just something that like I find super fun.
I think they've gamified it very, very kind of successfully. Um,
Yeah.
it's kind of big game poker of sorts.
I don't know if that's a good thing necessarily. Obviously, there's lots of like if you look at the code leaderboards, there's a lot of overfit. Actually, so one interesting thing to note is that if you look at all of the fine tunes of Llama 3 8B, uh, the one that is actually so in the past, like Llama 2, Meta would release Llama models, something, and there were all these people building these crazy fine tunes on top of it that would surpass them non trivially on the leaderboards. What we find actually is that this time around, Meta has done such a good job do, doing the fine tuning of their base model that their instruction tune model is the best of all Llama 3 8B fine tunes, and you'll find that like all the others are sort of overfit in various ways, and so I'm very delighted to see that trend sort of shifting. there was a Salesforce paper that came out that basically they said that they actually beat Llama's own fine tune, but they took it down promptly because of naming and licensing and this and that. But I played around with it a little bit and it's really good.
Yeah. And for these smaller models, Govind and Vishwesh, what do you think are like other use cases that come up which are top of mind? Is it like the recommendation engines? Because it feels like that is something that like comes top of mind for me when I think about all the consumer use cases, everything from gaming to social media to ad targeting. It feels like the recommendation engines that are going to be run by some of these smaller models are probably also going to be extremely powerful and are going to like help increase monetization across all of these consumer platforms and applications that people basically consume every day.
I think recommendations is one, but I think like the Rexis as a concept is this like huge, very well studied uh, field. It's unlikely that it's going to. I think what this will enable is a lot of smaller players to come up with uh, reasonably good recommendations off the bat, like without having to sort of solve the cold start problem that is usually an issue with recommendation systems. Right. I think the main thing is you can do all kinds of crazy on device stuff with smaller models. Like if you have a Gemma 2B,
Yep.
you can. There's like PolyGemma also, which is this vision model that Google released that is like really good. That you can fine tune really easily with a very small amount of data, like 100 samples or something, right? And so there's all kinds of like you can build like sports analytics tools and this and that. And I know Mozilla is embedding like a Transformer JS runtime directly into the next browser, and they're going to use some vision model to do like implicit alt text captioning, which is really useful. And I imagine a lot of other in browser, a lot of things that were formerly in the crowd are going to return to the browser.
Yeah, and
I've
not just good.
Right, good.
No, I was just going to say not just the browser, probably to our mobile phones and to our laptops and everything. I mean, we saw the Microsoft announcement, right? Like they're trying to bring back the PC, laptop, and like fight back to the MacBook, trying to say that hey, we're going to basically have hardware that is going to be AI, basically focused on AI. Thus, our PCs and our laptops are going to be better. And I think like this basically smaller models like these are going to bring the fight back to the hardware, where Apple, of course, has a monopoly. And I think like that'll be a really interesting thing that will play out over the next couple of years in terms of if Microsoft and other companies are basically able to take up this monopoly of a business, basically.
So one aside, I joked when I saw that the Copilot kind of like PC thing that only AI or AGI can use Windows, because humans don't really know how to use Windows anymore. But the one other thing I was going to say was that I feel like for something like recommendations, right? Like it really matters that you get a recommendation right. So you want to throw as much compute at it as possible. And so in such cases, I feel like recommendations, like if you've got an on-device kind of data store and you want to do quick recommendations on top of that, then I think those models can like sit kind of on edge. And everything else where you're kind of deciding, what's like kind of longer form content that you may be looking at, that probably still kind of stays in cloud. Um, I do think that the as you can kind of shift more into kind of the browser, you probably remove more kind of usage of apps themselves, because you can just if your browser kind of like increases in terms of the space and in terms of the kinds of models you can deploy, and if you can deploy them easily, then I don't know if you really need the kind of concept of like the kind of place that apps have held for so long. I think that could potentially shift back in kind of the browser's favor over time.
I mean,
So that's
I have a
one
question
possible
there.
future.
What apps do you even use on the day to day other than your browser on your
I
laptop?
mean, so for me, it is a combination of like Zoom, Slack, and then different IDEs. I know that like kind of. I mean, I'm surprised that Microsoft is kind of like with via GitHub was kind of trying to put the IDE really kind of like back on the map, and I think that's like actually a hard one to kind of get right, because developers are kind of notoriously finicky creatures overall, and so I think that getting that right will take time. But for a lot of the other things, I think Google was actually kind of like paving the way because they kind of built Chrome in this manner where they were just kind of cramming everything into Chrome. And so I don't know. I think perhaps you're right. Maybe it's already kind of happened. And you're just going to like sprinkle some AI on top. But I don't think that's happened on the phone yet. I think the phone still kind of remains as, kind of an app heaven.
And one of the things that I've been interested in and would love to get both of your thoughts on is actually like the fine tuning piece of things, which it feels like it's we are in the very early innings of smaller models and like people building it, but uh, what does fine tuning these models even look like, and actually building these models out, like how much data do you need? Is it like can you actually do with small samples, or do you actually need like still large samples of data to train some sort of like 8B model to fine tune it for your use case to get the kind of quality you would get from like a 70B model? Go, and I know you work with a bunch of these companies to help do something like this. Can you talk more about that?
Yeah, so I mean, we're able to fine tune models with very very small amounts of data nowadays. That is largely a result of more intelligent fine tuning techniques as opposed to anything else, right? So you can do fine tuning with 10 samples. The question is, of course, you know, what are the situations in which that actually surpasses in context learning? I think, like you said, it's those situations where you have to do really really low latency inference, right? Like if you have this, you have every example is 3,000 tokens. You end up with like 10 examples. You have 30,000 token prompt, which actually someone we worked with had 30,000 token prompt. Well, then every single unless these larger model providers let you do stuff in batch, which OpenAI has released something that lets you get 50% off if you pre-schedule your inference. uh, like that's going to take time, right? And or it's going to cost money, and neither of it, and people generally like waiting, neither waiting nor paying, right? And so in that kind of situation, if you can just compile that behavior into the model directly without having to do that, and sort of wait for all those tokens to be cached, it's quite valuable and quite helpful.
Yeah, and what is the actual techniques that are used to fine tune that, and what are some of the hurdles that people face in terms of like if I'm a developer at some enterprise, like why is it so hard to fine tune a model right now, and what and how do those hurdles actually go down?
I think that is non-trivially, it's mostly a result of sort of misunderstanding of how important the quality of data is, right? And so sometimes you have people come to you with like 1,000 samples or 500 samples, which is a great large amount of data because they think I need a lot of data. But what they fail to realize is unless all of the data is gold standard, you're actually often better off sort of pruning that data set down into a few gold star representative samples, right? And so I think one part of this is I think basically the entire stack for training a model has been very fragmented. I think there are some people trying to build visualization tools. Don't think they're getting very far. They're all like random open source that a few, people who are trying to train very, very, very large language models maybe play around with. There are people who give you fine tuning APIs, but they're not too flexible or work very well. And so there's folks like Axolotl and Hugging Face, right? That of course let you download these libraries and fine tune yourself, but that also requires one sort of technical know-how, understanding of what all these different hyperparameters mean, and then two, knowing how to fix things when they go wrong, and then three, provisioning hardware, which sort of are all very very huge structural barriers, right? Especially when the people who are trying to do ML these days are not traditional MLEs. They're sort of uh, guy, at best a guy who one day trained a bird, and at worst like my front end developer cousin, right? This is
Yeah, and I think I think one of the big pieces of that comes back to like the one hurdle that sticks really out to me is the data piece of things, which is people don't understand how high quality your data needs to be, and the way it's given to that, like the way it's given to that data and how high quality it needs to be is arguably lower than it should be. And then there is this whole question of like, are enterprises even willing to give that data to train some of these models? Unclear if they are, and which ones are, and like what data will be provisioned for this, and like how you actually go and implement that and use it into production is actually like all of that, all of those are like kind of more of the logistical parts of actually like of fine tuning a model and then actually deploying it. And I feel like very few companies have actually been able to like get through the bureaucracy of saying, hey, this is an important enough, and have prioritized it to actually go implement something like that. But I don't know if both of you have had a different experience from talking to enterprises as customers, or from friends you have and who are working at these companies.
Yeah, I think the other thing is for a lot of these enterprises, they know that they need to do something with AI, or they feel because all their their investors have told them that they've got to do something with AI, but it's not obvious what exactly they should be doing, right? And so you sort of default to the regular chat app or like the retrieval, ask questions about my documents use case. But I mean that requires very little fine tuning, in truth, right?
Yeah.
A lot of it is just like very good retrieval, which of course you can fine tune those embedding models and so on that play a role in this, but. Uh, I don't think people have really thought. People just don't know. They have a lot of data. They don't really know what to do with it. They expect when they come to you that you can find interesting use cases for them. And I think, I mean, there are companies that are basically at this point sort of just like consultants, effectively, right? That are
Yeah.
doing a lot of this stuff.
Yeah. Yeah, and
I
productizing
mean,
that will be very interesting.
Yeah, prioritizing is tough.
I think some parts of it can be productized, like this kind of one aspect of it, which is, you need someone who cares enough about the problem to actually try to solve it, which just doesn't exist at most places. Right? Like if you care enough about the problem, you would actually figure out that, data quality is important and that you need to kind of like have someone kind of like staff to kind of work through it. And in most cases, I'm not sure whether it hasn't yet kind of like proven obviously by kind of some competitor that they have to actually build it kind of in-house. That's kind of like one way of kind of having external motivation within the organization. But I think in most of these places, a lot of the times, I think it's just, you kind of know that you have like kind of the simple thing that you can do, which is take the data that you have, put it into a semi kind of organized format, and throw it into a model and see kind of whether that's useful or not. But that's not really actually building an internal product that or service that's useful. And so until someone actually cares and until you kind of see more people in kind of hired for those roles, I don't think it's going to make as much of an impact.
My view is that basically there are going to be a handful of companies who are going to have these high impact folks who are going to who really understand the power and have the right tools and the right knowledge to actually use these for mission critical use cases, and they're going to see like massive increases in usage and revenue, and really when they use it for these mission critical use problems, they'll kind of see an explosion in either whatever KPI they're trying to mention. And I think that is going to move AI from being just like this frothy concept that everybody wants to attach their name to and buy the .ai domain, to actually saying, hey, we actually need to go use it for our core business purposes. And this actually is a great segue to talk about one of the use cases that we've been hearing about a lot, and is which is the audio tech stack, which is like everywhere from the foundation model companies that are trying to build that are trying to build audio agents to, of course, companies that are building wrappers on top of it for different verticals. Vishwesh, Govind, what have you both seen with companies like 11 Labs and many others jumping in and raising big rounds recently?
I mean, I think it's going to be tough to compete with the large foundation model players on some of this, just because the really valuable voice API, voice agent use cases, many of them require low latency, right? And the best way, like the best system to, if you want low latency, the best system is an end-to-end optimized one, an end-to-end like, system, as opposed to a bunch of sort of various components cobbled together, as we saw, I don't know, the last year or so, right? I think number one, that stack is sort of reifying in some sense. But I think, or rather, I think people are starting to move away from these like disparate components. Like you have a speech recognition model, and then you take the transcript, send it to another LLM, take the output from that LLM, run it through some text to speech model. I mean, as 4.0 showed, you're able to get insane latency boosts by sort of integrating all of this, right? And there are other companies, Tin Cans and a bunch of others, and we've even thought about this in a philosophical sense. Is basically, if you don't want to actually train a model end to end to do speech in, speech out, what you can do at least is integrate make it so it's speech in, text out, and then you have text to speech, right? Which sort of gets you halfway there, and is a lot easier to build, because what you can do is basically splice on an audio encoder onto a text decoder, the way they have been for the image models, basically. Use a similar concept, and in the process, you basically ultimately get a model that just understands audio a lot better, right?
Yeah. I think it's unclear. Unclear who the winner is going to be. I agree with you that like the foundation model players are of course going to have like a massive advantage in the space. But I think there are going to be a handful of companies. There are going to be these massive companies that are going to be verticalized. And I think we spoke about this before, which
Mm.
is what is going to create really large businesses, even with these wrapper companies. And the conclusion that I've come to is the fact that it's going to be verticalization of many of these tools. And what I mean by that is, look at a tool like Salesforce, right? Once a company starts utilizing Salesforce, they actually build on top of it. So they start putting all the data in it, their insights are driven by it, and kind of the whole organization that becomes a one source of basically of truth. Now the question is going to be, can you build a tool or a platform pretty much around this tool where people actually build on top of it? You gather their data, you give them insights, and create some sort of a lock-in. And I think that lock-in is going to build a massive company, versus basically if you're just a wrapper company that is building, let's say, for dentist offices or something else of that sort, some other tool that has better latency, cheaper, is and higher quality for and fine-tuned for that use case is going to come and basically replace you. But if you're this platform tool that has, let's say, automations built for specific workflows for the dentist's office or for the chiropractor's office or something else of that sort, I think that kind of lock-in is going to lead to real stickiness amongst the customers that are trying to use a tool like this.
And again,
I
there's
think
like the value
it's quite
thing of,
possible.
yeah.
I mean, one of the things though is like if I consider my very very simplified version of the world, you kind of have AI companies as wrappers on like cloud companies or like kind of cloud systems, and then you have like kind of platforms as kind of wrappers on like kind of the big foundation models. I think there's still kind of ways, if you kind of get in early enough and build like kind of exactly, if you kind of aim exactly in the right space in the entire industry, kind of like space, that you can get into the right position to be able to expand over there. It is, I think, harder to find exactly where the right location is, but I don't think that the kind of vision that you're describing is like actually all that hard to kind of see happen, right? It's quite likely that there can be multiple such companies that are built like that, but I don't know if they're. I think they're going to be big companies, but I don't know if they're going to be like kind of cloud slash foundation model big companies, right? And
Yeah.
perhaps that doesn't necessarily matter all that much, but it does. The only kind of assumption that you need for that is if you assume that over time we're going to keep pushing more and more kind of dollars still towards kind of like cloud, and that may happen, that may not happen, and I think there are kind of different universes over here.
Well, walk me through the circumstances in which it may not happen.
I mean, I think that we do kind of like want more compute in general, but you can shift more compute onto the devices that exist already. Like the phone that's sitting kind of next to me has pretty decent hardware, but is mostly right now just pinging a server trying to see if there are notifications for it, and that's it, right? But you can have, like, instead of having so much of my recommendations being run on like massive server farms sitting kind of in kind of like polar regions in the world to kind of offset kind of global warming and kind of energy constraints, you can shift, if you shift like 10-20% of that compute onto existing hardware. I think there's so much kind of compute logistics that can happen um, for all of the different systems that are there. And cloud systems are very, very well organized. The problem is that you can't consider small bits of compute and move the memory and kind of compute in kind of easy manners. And so if you have systems, so my main thought process over here is based off of a lot of the omics work that was done at some point, right? You had these biological systems and kind of compute systems where they would just say, hey, just open up your machine, give me a little bit of time to run a large compute job on your machine, right? And you could assume that these things can be orchestrated in such manners that you can just use hardware that is not yours, as long as you kind of take a little bit of money off of it. It's kind of a pseudo kind of crypto style framework, maybe that you can
I mean,
play with there.
I think there's I mean, decentralized trading is always like one of those great dreams, right? But it's tough because you
I
basically, with LLMs at least, you have to like shuffle around large gradients, which are like gigabytes large, which is tough. All right, and the only real use case in which you'd really want to do decentralized training is when you're trying to train like some like trillion parameter model, right? So, and trillion parameter models, the gradients are even larger, so it's like this catch 22. Uh,
But I
and
think that
really,
in terms of like training versus inference, like I mean, right now we're kind of at half and half on training versus inference, right? But over time, I'm not sure if you kind of keep reinvesting in training. I think that it shifts like kind of 30-70 or even more in kind of just inference. And inference capacity can be split up, right? Inference capacity by definition can be split up. And training capacity, I agree with you. I think training kind of remains centralized. And they're building kind of enough compute to kind of centralize training.
Also, Vishwesh, one of the things that you mentioned is like how big are these companies going to be? Going back to that point, I think there are two factors here, right? One is the fact that these foundation model businesses, of course, like there are only a handful of them, and given the amount of capital they require, of course, like their valuations feel very very high, and there are just going to be like many many more application businesses that are going to be built on top of it, and they'll be more world class, so they'll be much smaller. But the one thing that and the one question, the open question is how fast are these foundation model businesses going to get commoditized? Because what it feels like is like we spoke about, like all this stuff is going to get commoditized over time, and it's getting commoditized even quicker than before. So how are investors really going to value OpenAI when like churn on the product might be really high because Meta comes up with a model every 3 months, and then OpenAI has to, and thus they have to basically keep reinvesting and basically pumping capex into the business in order to remain competitive. So unclear if how big these businesses will be. I think time will tell, but at least in the short term, these feel like gigantic businesses that at a scale which is kind of unseen in the valley or across the world before this, pretty much.
and I guess there's an argument to be made
I
that
agree.
there's nothing really stopping an application like some kind of GPT wrapper from theoretically surpassing or at least matching the value of one of the smaller foundation model companies, just because they don't have to make their business is more attractive because they don't need large capex, right? Someone else,
I mean,
and like, if you can instead, you can just like get by on Gemma 2B, right? uh, then that's probably a great business.
And that is the very interesting thing, which is actually if you go talk to SMBs, they really want to utilize lots of AI, but given the fact that like they have small workforces with like limited engineers on the team, they actually are like constrained by those factors. So they're trying to look for these out of the box solutions which are low latency, low cost, high quality, and you can pretty much just like don't have to fine tune the model, and you just need like one or two people or even basically no people to go run it. And I think like that is such a massive opportunity, and if you can capture like all of these businesses, let's say from everywhere from the barber shop to the gardener, everybody who needs to pick up a phone call, I think that is just like a massive, like that's a massive business to waiting to get built.
And I think agentic systems will also, over time, sort of like the idea of you have this like master orchestrator and a bunch of smaller models that you actually sort of outsource work to. I think is very likely to be the system that we end up settling on. So I think even in that case, small models are still quite valuable because you don't need to be able to. reason about very very complex things, but if you can, just do the task that you have been assigned, this has been broken down into some bite-sized piece, well then, and you can do that on the user's system, that saves everyone a lot of money.
But the one thing I don't want to underscore is the fact that and like people kind of talk about this a lot, which is it's like the foundation model companies are chasing the $1 trillion prize, which is whoever basically runs away with this problem uh, builds the next $1 trillion company. And I think that ambition is what makes this almost like this arms race really special. The fact that the prize is pretty much as big as like pretty much you can build the next Microsoft, next Apple, if you go solve and can run away with something like this.
I mean, I think certain aspects of kind of I think this is all kind of like quite likely true, right? I think the one thing that I think about a lot is kind of like the and maybe we've talked about this is the similarity between kind of the networking build out versus kind of the AI build out, and it's always like a lot of the times when we focus so much on like the foundation model companies, it's not immediately clear. Like we think of these guys as providing the platform, and then the product is built on top of it, and the product doesn't accrue that much value. And you could argue that it's the flip that happened over like the 2000s and the 2010s, where the kind of platform didn't really accrue as much value in certain cases, and the kind of products accrued a lot of value. And so I'm kind of like 50-50. I think that there is this kind of so much obvious value built into any of these foundation models that is just latent, right? Like you don't need to try, and you just get so many things for free. But at the same time, there is so much kind of craft that goes into building a product that users actually like and love. And I don't know if you get that much for free from a foundation model, right? And so really kind of unlocking the last section where you're closest to the cash flow from the user's perspective is actually where a lot of the earnings come from. And so I'm not kind of like, I'm kind of on both sides of the fence here, where I'm just like, the foundation models
And
are obviously awesome, and on the flip side, but like product is actually where it's at, right? So I'm not
and
sure.
and no, and you're totally right, and that's also why the product actually accrues value at the end, because these platforms need to be built first for basically all the product companies to go start playing around with it, and then it actually of course like over time takes many months and years to really figure out this really easy solution that each and every restaurant can go use, and like where the next toast is going to be built. And once you
Mhm.
start really you build that product that people love, then the value that gets accrued to that is explosive.
Yeah,
Yeah.
no, I completely agree with that.
Because let's be honest, which restaurants give a crap what AI model you're using? All they worry about is, can you help us optimize our supply chain way better than before? Yes, AI models probably can, because they can probably provide better recommendations, better understanding of what the business will look like in the next 6 months, which items get ordered the most, and how do you actually go optimize your supply chain on the basis of that, and which model gets used unclear if that is going to be if that is going to be the big point of contention, because if the people love the product so much, it doesn't really matter.
And yeah,
Yeah.
and I think there's going to be a lot, again, like you said, $1 trillion prize, right? It's like the first person who unlocks this will is sort of like the great victor of the great race. And I think second and third place basically get like a rotten apple, right? Unless of course you believe that all of these model companies are going to hit or like roughly similar level, or will get to similar levels around the same time, if whoever unlocks general intelligence or like something close to it, or even like I think there's a lot before even general intelligence that is very economically valuable. That
I feel
like
like we're already at like kind of points there. Like if you showed this to someone like 2015, they would be like, "Shucks, this is even beyond general intelligence," right? So like it's kind of like it's the same question around like the small model thing, but like a real question now is just like, okay, so what is AGI? But I guess we don't need to go there. But
future
I think
podcast.
the big problem is that it's like, okay, so in terms of like when general intelligence happens, like it's like this, people consider it this like massive discontinuity. But then the scenario of like, okay, let's say that we stop here, right? How does this play out for the next 10 years? And I think even forecasting that is insane. And when people try to add the discontinuity on top of it, I'm just like, you can't predict that. Not at
Yeah.
all. Don't even try. Right?
and, and I sort of agree with Govind in the sense that that is going to be this one massive winner. Totally agree. But I think there are going to be like smaller foundation model companies too, which are going to be niches for, let's say somebody creates the best audio model or a regional model or for some other specific use case. And I think those companies will be large, probably not $1 trillion business unless they're tapping into, like, unless you're building the next software engineer and you have that best model only in that niche. But unless that is the case, it feels like the company that's producing like more general intelligence might be the winner, versus like some of these niche players. But I think there are going to be multiple winners in the space, of course, like not $1 trillion.
Hmm.
Hmm.
I think
Good
that's
point to
a
wrap.
Yeah, I think that's a great point to wrap up on. Thank you so much, everyone, for listening, and we'll be back next week. So-
Awesome.